Hey everybody, and in this video I have a book here, and it's called Elementary Number Theory, and it's written by Underwood, Dudley, and if you notice here that the cover has an unusual scheme where it's got green on green, so it's almost impossible for you guys to see, but these are just digits, or 0 to 9 numbers. And so you're probably wondering, if you haven't studied it already, what number theory even is. And number theory is just the study of integers. And so you can imagine integers are just a number line, and it's the whole numbers, both positive and negative, along the number line. And so that's what number theory is. And elementary number theory is like an introduction to the topic rather than an advanced analysis of numbers. And the study of integers is quite fascinating. And even if all of the theorems were lost for number theory, society would continue to churn on quite normally, as normal as it was before, meaning the applications you learn in number theory don't really have any real world implications. And so maybe that's why number theory is not really taught until much later in mathematics in the curriculums in the United States. Maybe that, and because it's relies on logic and proofs. But I'm of the perspective that it should be taught much sooner. It should be taught, right after elementary algebra and geometry, and probably should be taught in high school. I'm also of the perspective that we should be studying logic and proofs and writing proofs in high school. But yeah, this is elementary number theory, and I've read through this book, and I think this book is the best if you are just being introduced to the topic. If you've already studied number theory a little bit, then maybe this would be a little too basic, but it hits all of the concepts really well. And like I said, you don't need anything other than algebra and geometry. So this book's actually written in at least it was published in 1969. Don't know why that's not. And so if we take a look here at the contents, we have integers, probably defining them, unique factorization, Diophantine equations. It goes through the proofs and some of the issues. And this is before Andrew Wiles, so it doesn't have his discovery. Congruences, modulo, linear congruences, Fermat's and Wilson's theorems, the divisors of an integer. Yes, so there's divisors is the main a new concept you might be exposed to within number theory, and that's just a way of notating the relationship between integers, the relationship between prime numbers and multiples of primes and stuff like that. Perfect numbers, Euler's theorem and function, primitive roots and indices, quadratic congruences, quadratic reciprocity, number of other bases, number in other duodecimal system. I did a video on that. I've also done a video on number theory, so do check that out. But yeah, the duodecimal system is fascinating to me. The whole number system using different bases is fascinating to me, but very, very difficult to actually learn and use. Decimals, Pythagorean triangles. I swear, any math book that lacks a mention of Pythagoras is probably not a good math book. Infinite descent and Fermat's conjecture, sums of 2 squares, sums of 4 squares, x squared minus n, formulas for primes, bounds, and miscellaneous problems. And so, yeah, this is a really good book for an introduction to number theory. And so you can get this, and I'll leave a link to where you can get this book, maybe. I'm not really big on that. I don't really like leaving links. And so, yeah, this is Elementary Number Theory by Underwood, Dudley. Written a long time ago, but still, with math, doesn't change with time. Once you prove something, and it's proved, and that's it. Unlike science, which can be, changed with time, math does not. And with that, we'll see you in the next video.